Good evening, everyone. My name is Lindsay Spear. I'm the campaign director for HeatSmart CNY. We're a community program of the Alliance for a Green Economy and the HeatSmart CNY campaign. I'd like to introduce Dick Kornbluth, who is our home performance advisor for the HeatSmart campaign. He's going to give the presentation on both Heat Pumps 101 and the basics of insulation, which are important for all of our homes to reduce our energy use and specifically make a big difference in heat pumps. Dick, I'll let you take it away.
Thank you. Thanks, Lindsay. Thanks, Allison. Welcome to Heat Pumps 101. My name is Dick Kornbluth, and I will be presenting. First, we acknowledge the Onondaga Nation. We live on their land, and they are historic owners of this part of the world. And it just happens that their fire barn uses ground source heat pumps, and we'd like to point that out and acknowledge that. So HeatSmart CNY, who we are, well, we had more than 1,200 participants. We've done more than 100 events. We've had more than 116 projects approved and have removed over 480 tons of CO2 from New York's atmosphere. We're a not-for-profit project of the Central New York Regional Planning and Development Board. We're funded by NYSERDA. We do two things, basically. We provide information on energy efficiency and new heating and cooling technologies, and we connect community members with installers and resources. So where do we operate? We operate in the following counties: Cayuga, Cortland, Madison, Onondaga, and Oswego, basically the 5 counties of Central New York. So if you live in one of those counties, you fall within our territory and we can serve you. If you don't and you are outside this area, please contact us, because as you'll see it toward the end of the presentation, there are HeatSmart communities all over New York, and we can link you up with the one that serves your area. So what are the main sources of greenhouse gases in New York State? The transportation is the largest single source, but coming in a close second is buildings, which is 30% of the sources of greenhouse gases in New York State. And that's the focus of what we do, is to try to reduce greenhouse gas emissions in that sector. This is a slide that was provided by NYSERDA, and there was a law passed in 2019 called the Community Leadership and Climate Protection Act, called the CLCPA, which mandated dramatic reductions in greenhouse gases over the next 10, 15, 20 years. Starting with a base of 1990, it's a little hard to read the legend, but I can quickly tell you that the orange, which shows up as a little red, is for non-fuel greenhouse gas emissions. That could be things like lighting, et cetera, and appliances. Building combustion is the dark blue, and building electricity is the lighter blue. Transportation electricity is barely visible as a tiny little light blue line, and at the bottom is transportation combustion. And these lines represent these sectors as sources of greenhouse gases. So starting from 1990, the goal is to reduce greenhouse gas emissions from New York State by 40% by 2030, which is the gray line, and 85% by 2050. So this is the dramatic goal of the New York State legislature and the New York State community. So let's talk about the role that heat pumps play in this. When you look at the residential building sector, where is the energy used? What is the largest sources of greenhouse gas emissions within the residential energy sector? And it's really in space heating, water heating, and space cooling. And if you add the 3 together, they account for 70% of the greenhouse gas emissions from the residential energy sector, which is why we're focusing on heat pumps, because the potential for reduction is greatest in that area: heating, cooling, and water heating. So let's look at heating costs. You know, what is the largest heating cost in terms of BTUs, and the largest cost to heat a building in terms of resistance electricity. We're not talking about heat pumps, but we're talking about electric resistance heating is the top line, and everything else is relative to that. And the second largest is propane. This data actually came from September of 2021. So it's the most recent data I could find online on heating costs in New York State. And it represents the average of heating fuel costs in the state overall. So it could vary significantly or a little bit in one part of the state or another, but these are statewide averages. So you'll notice that resistance electricity is the highest cost to heat a house or a building, followed by propane, and heating oil, natural gas. But if you actually replace any of those heating fuels with air source heat pumps, you'll notice that that instead of electric resistance heating, which is $6.01 per unit of energy, it drops down with air source heat pumps to $2.40 because of the incredibly high efficiency of those units, which is about 250% over resistance heating, and $1.50 for ground source heat pumps, which is more than 400% of the cost of resistance heating. But what's important is to compare the cost of heating of air source heat pumps and ground source heat pumps with delivered fuels like propane and heating oil. So air source heat pumps are half the cost to heat the house as propane, significantly lower than heating oil. And ground source heat pumps actually are 3 times lower cost compared to propane, and half the cost of heating a building compared to heating oil. Natural gas prices have risen dramatically in the last year. I was stunned when I saw the pricing that has been collected by the Energy Information Agency on gas prices, natural gas prices, and air source heat pumps are still slightly less expensive in terms of heating a building than natural gas. If you are interested in finding the carbon footprint of your house, and which means how much carbon dioxide you are producing living in your house, there's a handy calculator run by the EPA. The link to that calculator is in the chat, and it requires very little input on your part. Basically, how many people live in your house and your zip code, and a few other pieces of information, such as your heating and cooling costs, and it will do a fairly interesting job of calculating your carbon footprint. But the first step in any of this work is to get an energy audit. So what is an energy audit? Well, it actually begins with a discussion of what your concerns, including energy, comfort, and other issues. Keep in mind that it's not simply a matter of addressing the energy costs, but it's also a matter of addressing issues that your house has that relate to comfort and durability and maintenance. And I'll get to a list of that in a minute. When you get an energy audit from a home performance contractor, they will meet with you. They will discuss the issues you have living in your house. They will then inform you of solutions, which may include insulation and air sealing, along with converting your heating and cooling systems to heat pump technology. They'll provide the data you need to properly size the heat pump, and then they'll give you a proposal. So what do I mean about home performance contractors? Well, they're not really just insulation contractors, and they're not really just HVAC contractors. They're really in the business of solving problems. And those problems can range from rooms that don't heat or cool sufficiently, drafty areas in your house, moisture or humidity problems or ice dams. And finally, at the bottom of the list, but last but not least, is high energy bills. So it's really about the environment in your house and how you interact with that environment and the issues that you have living in your house. And those are the kinds of things that a home performance contractor can address and fix. So the next step would be improving your home performance with insulation and air sealing. So you might be saying to yourself, I'm thinking about getting a heat pump heating system. Why should I bother insulating and air sealing my house? Well, for one thing, it'll save you money with your existing heating system. So even if at the end of the day you decide to postpone, installing a heat pump heating system in your house, the insulation and air sealing will actually save you money with your existing heating system, and you should do it for that reason alone, even though it provides significant benefits when you upgrade your heating and cooling system. Secondly, it can, if you insulate an your air sealer house, it'll actually lower the cost of installing and operating your heat pump. Heat pumps are sized to the building load, and which is how much heating and cooling your house needs, which is a function of how well insulated and air sealed it is. So the better your house performs in terms of insulation and air sealing, the smaller the capacity of the heat pump that's installed can be, and therefore it can result in more efficient operation and lower cost. Heating system. Climate change has drastically affected Central New York. In the 25 years I was insulating houses, we would have 130 to 170 inches of snow each year, and houses that weren't well insulated can have massive ice dams with all kinds of damage, both to the house and risk to people walking around the house. We don't see much snow anymore, but when we do, if we do have a significant snowfall, you will have ice damming problems, and they can be solved using insulation and air sealing. And finally, insulation and air sealing reduces your carbon footprint, which is the ultimate goal of the energy policy of the state of New York, and saves the planet. So let's talk about insulation. For attic insulation, if you, depending on the area of the house and the construction of the house, it can be either spray foam insulation, which would insulate the roof deck of the house, under the underside of the roof deck, or if you have a big flat open attic, it would be loose fill insulation such as cellulose or fiberglass or rock wool. So this is a cellulose insulation installation, and this is spray foam on the roof deck. Both of them are totally appropriate given the structure of your house and the needs of your house. The second big area that really should be addressed with insulation is the basement rim joist. The basement rim joist is the area in the basement of your house that's where the floor joists that support your first floor sit on top of the foundation wall. That is normally an area where there's nothing there but 2 inches of wood, 2.5 to 3 inches of wood between the inside of your house and the outside exterior world. In addition to that, the framing that's there can sometimes over time and over the years be leaky and be an issue in terms of air leakage. So it's really cost effective and highly recommended and cost effective to have the rim, what's called the basement rim joist insulated, normally done with spray foam, as you can see in this drawing. The third area of your house that really should be addressed, and most people don't even think about it as a possibility, is insulating your sidewalls. If you'll notice in this image, there's a single panel of aluminum siding that's been taken off the house, and the installer is insulating the entire stud wall from the bottom to the top, which is between 7.5 and 8 feet from that single hole. So depending on the siding, whether it's standard clapboards or wood shingles or aluminum siding or vinyl siding, access to the walls can be done by taking panels off and drilling the holes, installing the insulation, and literally putting the panels back on. But done by a skilled professional installer, it's possible to insulate the sidewalls of your house and leave very little evidence that that this installer was there. The aluminum or vinyl panels can be put back on and zipped together. If it's wood clapboards, they would need new nails, and other than that, there would be very little disruption to the actual visual appearance of your house. So it's not necessary that any part of that outside cladding would get damaged. What's really important to know about sidewall insulation, by the way, is that it's incredibly cost effective. Not only is it saving a lot of energy and it's cost effective in terms of energy saving, but it has a dramatic effect on comfort because it reduces air leakage through your walls, and it reduces outside noise. So it's great soundproofing for your house. So you should seriously consider doing that in any house that you live in that was built before, basically built before 1980, when New York mandated sidewall insulation in new construction. So I want to talk a little bit about wool sweaters. It's hard and it's not obvious why a wool sweater would be relevant to a discussion about insulation. But if you think about a wool sweater on a calm, very calm winter day, it does a really, really good job of keeping you warm, but not so good when the wind is blowing, because wool is porous. Air can go through wool. So when the wind blows through the wool sweater, your body is cooled off and your comfort goes away, which is why when you go out on a windy day, you put on what's called a windbreaker. So what the windbreaker does is it stops the wind from going through that wool sweater you might have on underneath, and in effect restores its insulating value so it continues to keep you warm. Well, houses are kind of like people with wool sweaters, except that there are holes in houses that you actually can't see because they're hidden in the structure of your house and they're not obvious to you, but they exist. And what they do is they allow in the wintertime warm heated air, because heat rises, we all know warm air rises, to escape through these hidden gaps and cavities and escape through into your attic, for example, where it might literally warm up the roof and melt snow and make ice. Even if your attic is fully insulated, you can still make ice on a roof if you have air leaks. So where are they? Well, they're in the hidden framing around chimneys, for example, because you can't put a chimney against a piece of wood. So there's always a gap between the chimney and the framing. Or the most classic example is the soil pipe, which runs basically from the basement all the way through your house and exits the roof. You don't see that because it's inside a wall, but that gap around that soil pipe is a giant, basically a giant highway for warm air to escape to the attic. If your attic hatch is not weather stripped and sealed, it will leak. If you have recessed lights in your house between your living space and your attic, they will leak. Around any kind of penetration of your ceiling on your top floor, unless it's been intentionally sealed, it will leak and leak air into the attic. So at the same time as you're leaking warm air out of your house, because nature doesn't like a vacuum, it wants to replace that warm air with air from outside. And that's usually done at the bottom of the house. So you'll notice that there's cold air, which is outside air, leaking into the house at the bottom. So you have two things going on simultaneously: warm air leaking out the top and cold air leaking out in the bottom. And that's one of the things that insulating the rim joist in your basement will stop. So how do we find all of these leak spots that I just showed you? First of all, air sealing, which is the way you find them, is just like the windbreaker over the sweater. Because fiberglass insulation is like a wool sweater, it's porous, air goes through it, as does wood fiber cellulose or blown fiberglass or blown rock wool. All of those loose fill insulations are not airtight and the air can go through them. So what we do is, instead of allowing that air to leak through, we air seal those gaps and then we create what's functionally a windbreaker for your house. So how do we find those gaps? I'm going to tell you a short story and give you an example. So this is a summertime project, and this was several buildings at Lemoyne College built for student housing. And one winter, the first winter these buildings were built, the ice dams were so severe that they had to block off entrance at the front of the building. The buildings are on a hill, so there's a back entrance in the back of the building down below, and they forced the students to go in through the back entrance. What's important to note here is that these buildings are not that old, and they were built to all of the existing standards for energy efficiency construction in New York State. So New York State mandates that walls be insulated, that attics be insulated, but New York State did not mandate that the attics be air sealed. So they had massive ice dams that were causing potential damage and threats to people's lives, literally. So I was called in to see if I could find out where those leaks were. And what I did is I had an infrared camera and a blower door. And a blower door is a fan that's mounted in the outside door of a house. It's a big fan. And what it does is it creates a little vacuum. It pulls air out, creates a vacuum. And nature not liking a vacuum will cause whatever air that's in the attic to be pulled into the living space through the same gaps that it might be escaping in the wintertime. Now, keep in mind that I'm in the summer, so I'm not looking for cold air leaking in. I'm looking for hot attic air leaking into a cool space. So what you see is the bathroom, and without the blower door running, you're looking at a fairly uninteresting picture. And when the blower door was turned on, all of a sudden the room lit up. And it was lit up because all of those light colored areas are walls of the bathroom that are interior walls filled with attic air, hot attic air. So clearly there was issues with the framing and with leaks around plumbing and electrical outlets, etc. So I went into another room. Once again, this is the digital image. And once again, this is the image with the infrared camera with nothing going on with the blower door. And when I turned the blower door on, there's what happened. You're looking at basically hot attic air being sucked down into the interior of the walls of the interior walls of the building. So there's leaking issues having to do with the framing of the building and electrical penetrations and plumbing penetrations, all of which would have to be sealed to stop the ice dams from forming. So this is a tool that your home performance contractor can use, and the winter time is the absolute perfect time to do it, because the bigger the temperature difference between the inside and outside, the more dramatic the visuals are when you do this kind of investigation. So how do we air seal? Well, you just use whatever is appropriate for the hole that you're sealing. In this case, we have electrical hole, a hole through the top of a wall through which wires have done, and spray foam was used here, except the contractors that you'll deal with are going to use much more sophisticated spray foam equipment to do this work. You might have an electrical box in a ceiling that has holes in the box and is not well sealed into the ceiling that can be sealed. There might even be gaps between the top plate of this wall and the sheetrock below attached to the wall to be sealed. So there's all kinds of opportunities to do this sealing work. So moving on to heat pumps. There are essentially 3 heat pump technologies that can meet your home energy and comfort needs. If you're talking about space heating and cooling, there's both a ground source heat pump system and there's an air source system. In the case of hot water heating, the ground source heat pumps can provide that along with dedicated heat pump water heaters. What is common to all of these technologies is that they operate on basically the exact same principle. And the principle is that they do not create energy by burning anything. What they do is they transfer energy from heat energy or take heat energy away in case of cooling from one part of the world to another. So they're, in the case of air source heat pumps, they extract heat from the air outside and they bring it inside. In the case of ground source heat pumps, they extract heat from the ground below the frost line, where the ground is always a constant 50 degrees or so, and they bring that heat into the building where it can be turned into useful heat to heat the building. In the summertime, the whole process can be reversed, so they can take heat out of the building, essentially using the same technology in reverse. For example, your refrigerator is basically a heat pump. It's taking heat out of the interior of the building and it transfers it into the kitchen. So heat pump technology uses the same principle. And finally, there is a dedicated heat pump water heater, which simply does the same thing, but it's inside your house and it's taking air out of your basement and using it to heat the water inside the heat pump water heater. And we'll talk more about that a little bit later. So these are the basic components of heat pump technology. So what are the benefits? First of all, as you saw earlier, they can drastically reduce your energy costs. They produce more even temperatures. In some cases, depending on the technology you use, you can create different zones. You can quite literally heat different rooms differently with different controls for each room if you actually want to go there. Because there's no combustion, there's no carbon monoxide or any other air pollutants. So they create a much healthier environment, and they drastically reduce greenhouse gas emissions, which is what everybody's goal is in New York State right now. And because they run on electricity, if you combine them with solar PV, you can get even more savings in terms of operating costs of your building. So we'll look quickly at air source heat pumps. There are essentially two kinds. There's a non-cold climate air source heat pump, which is suitable for climates down to about 30, 35 degrees. And then there's a very, very specifically designed cold climate air source heat pump. And that heat pump is an air source heat pump that is literally capable of delivering useful heat into a building when outside temperatures are below 0 degrees. And they are the heat pump of choice when we're talking about installing heat pumps in central New York. They are different configurations. There are what's called a ductless mini split, which has a single zone. It basically conditions a single room or a common area. You can take a ductless mini split and you can have multiple zones, which and we'll talk a little bit more about what that looks like, where you have a single outside unit, but it might heat several different zones within the building that can be independently controlled. And finally, you can have an integrated or ducted multi-zone system, which essentially uses your existing heat distribution system, which would be your furnace and your ductwork, or the air handler in your furnace and the ductwork to actually distribute the heat throughout the building with an outside unit to do the transfer. So this is a ductless mini split, and you'll notice there's an outdoor unit and an indoor unit, and connecting them is a refrigerant pipe. And that refrigerant pipe will run up the side of the house and be attached to the indoor unit. And you can have several of these for different areas of your house. So you could have 2 or 3 or even more separate mini splits if it's appropriate for the heating of your house. Real quickly, the outdoor units, they're not very large. They look a little bit like an existing, they're usually a little smaller than existing air conditioners, outside air conditioners. And the one thing I want to point out is this one, which is right in front of a deck. And the purpose of my pointing that out is that they tend to be really, really, really quiet. They are not noisy at all. And in this case, they were so quiet that it was possible to install the heat pump literally right outside the deck, and people were still able to use the deck and enjoy the use of the deck in the summertime. So they're incredibly quiet devices. On the inside of the building, there's also some options in terms of the indoor units. They can be usually most commonly mounted on a wall, as you see, or they could be mounted on the floor, or they can even be mounted in a ceiling with a ceiling unit. So you would talk to your installer about the best possible way to install these things and what configuration works best, but you can see that there's all kinds of variations that can be done here. In the case of a ducted air source heat pump, there's a single outside unit, and it delivers through the refrigerant. It delivers it to the interior of the building, where inside an existing furnace might be a heat exchanger that would extract the heat out of the unit and then transfer it to the ductwork so that you can basically heat and cool your whole house. It is compared to traditional, for example, central air conditioning. They're much more efficient than central air conditioning, and they have the second benefit of actually providing not only cooling but heat, as we mentioned. So this is an example of an air source heat pump system in a house. In this case, there were 2 outdoor units and 4 indoor units, which means that each outdoor unit was multi-zone because it serviced 2 indoor units. And when this job was done, the initial cost was $18,838. There was a NYSERDA rebate of $4,000, but there was a better rebate from the utility company of $5,360. So the net cost to the homeowner was $13,478, and it was done along with extensive insulation and air sealing. Air source heat pumps are not just for residences, they're used in commercial buildings, and there's some examples from Central New York, the Preble Town Hall, the Hamilton Fire Department, the Sinclair. I don't know what that building's used for, but it's a large old building in Skinny Atlas. Probably the most interesting case study was the hybrid heat pump. What happened in this case is the homeowners called the contractor for an insulation estimate, and in the process of doing the home performance energy audit, discovered that their old gas furnace was quite literally generating carbon monoxide. So what started out as an insulation and air sealing project turned into a whole house project, which included a heat pump system and a furnace replacement to a 90+ efficient furnace. So what that meant was that they had the benefit of the heat pump for most of the year, but on the absolute coldest day of the year, if it got really, really cold, the furnace was capable of producing heat, supplemental heat for the heat pump. So let's talk about ground source heat pumps. Basically, a ground source heat pump has two basic parts. There is what's called the loop field, which can either be vertical, which means that it's a well, and the well is drilled through a 6-inch wide hole, and it usually goes down anywhere from 250 to 500 feet. And in that hole is placed a loop of tubing, which is polypropylene tubing, and in that tubing, which is the transfer medium of heat from the outside to the interior of the building, is non-toxic propylene glycol that's mixed with water. So it's like basically an antifreeze, or it can be a horizontal loop field. If there's enough land behind your house, it can be done in what's called a loop field. And you'll notice it's the same polypropylene piping filled with the same material, basically polyethylene glycol, and but instead of a well, it's laid in trenches that are dug down below the frost line, and then the refrigerant then is brought into the building, and when it gets into the building, it's delivered to this device, which looks a whole lot like a furnace, except it's not really a furnace because there's no combustion going on. But what it is it's a compressor condenser that actually does the transfer process of getting the heat out of the polypropylene tubing and delivering it into the ductwork or into the hot water delivery system, into the hydronic delivery system of the house. So here's a bunch of houses that have had ground source heat pumps installed. And what you'll notice about them is there's no special kind of house that's appropriate for this. It can be a modern contemporary house. It could be a sort of traditional house like this house might have been built in the 60s. Or it could be a really, really old house like this house, which was built in the early 1800s, is my understanding, right outside Syracuse and Pompey. And we're going to talk just a minute about and briefly about this house. This house basically had a 4-ton geothermal system installed. There was a NYSERDA rebate and a federal tax credit, which brought, and a national grid rebate, which essentially cut the price by more than 40%. In addition to that, there was an electric service upgrade because of the requirements for running a compressor. There was also insulation and air sealing done and some modification to the ductwork. And finally, the homeowner had a solar system installed. And at the end of all of that work, her utility costs have been and by the way, I know where that house is. It's on the side of a hill, and it's incredible wind that blows through that area in the wintertime. So it's a really, really challenging environment. And in spite of that, her utility costs since the work was done have averaged about $20 a month. This was a more complicated house. It was a geothermal home. It was also heated with natural gas. 2,000 square foot house, had 2 vertical wells drilled of 250 feet. And then afterwards, the land was leveled and reseeded. The initial cost for the heat pump was $65,857. And after incentives, it was cut down to about $39,000. In addition, they installed a solar system. And after all the credits were issued for the solar system, including a grant from NYSERDA, federal and state tax credits, the net cost was about $19,000. So the savings in both were dramatic. It was a 44% reduced cost on the heat pump and a 52% reduced cost on the solar panel. So what happened in this house? If you look at the cost of heating, before they were using about 893 therms a year, which cost them about $1,000. I can tell you that natural gas prices are significantly higher right now than they were when this project was done. So that cost would have gone up significantly. Afterwards, the energy usage was no longer measured in therms, which is a measurement for combustion of natural gas, but it was measured in kilowatt hours. I took the liberty of translating that 3,400 kilowatt hours into therms so we could compare usage before and after. There was literally an 87% reduction in the use of energy in that house after the work was done. And the cost of basically the operating cost of their heating system was reduced from $995 to $340. But more significantly, they were producing 3.2 tons of carbon dioxide a year, and that was reduced to 0.4 tons, which was a dramatic reduction. Ground source heat pumps are not just for residences. They are found in commercial buildings of all sizes, including the Auburn Memorial City Hall, the Marcellus Library, the Pike Block in downtown Syracuse, and a large building in SUNY Oswego called the Scheinman Science Center. These buildings are all heated with ground source heat pumps. So very quickly, a quick comparison in terms of energy efficiency, air source heat pumps are very efficient. Ground source heat pumps are a little better. In terms of using the pre-existing heat distribution system, which is either ducted or hydronic or radiant floor, for ductless mini splits, the heating is directed into the house. They do not use a distribution system. Ducted versions are available. For ground source heat pumps, they do require a distribution system. They can either use hydronic or ducted air. Both provide air conditioning, except obviously if the ground source heat pump is simply servicing a hydronic heating system, it would not automatically be used for cooling. Each head in an air source heat pump is essentially working its own zone, and each head can have separate controls. For a ground source heat pump, zoning is something that can be built in. It's an extra feature. The average lifespan of an air source heat pump is about 15 years. For ground source, the mechanical equipment is about 25 years, roughly equivalent to existing furnaces. But the ground loops, which are totally passive devices, have a 50-year plus lifespan, and probably nothing short of an earthquake is going to damage them. There's almost no weather sensitivity for either, as long as they're installed properly. And for air source heat pumps, there's no disturbance to the grounds. For ground source, there's a whole lot, but it's a one-time event, and there are really good incentives available right now for both kinds of heating systems. Finally, heat pump water heaters. What they do is they use the same technology as an air source heat pump, except that they take heat out of the atmosphere around the water heater, and they deliver it to the water inside, and then they let cooler air out. So what they do is they will have a tendency, because they are extracting heat from the outside air around them, they will have a tendency to cool that environment off. They also have their basic configuration is such that they're fairly tall. They can't really be installed in a closed space like a closet because of their need for accessing outside air. They are not, unlike a natural gas water heater, which is essentially silent. They have a fan, so there is a certain amount of noise from them. They are incredibly efficient. They are the most efficient way to heat water that is around right now, but they have to be appropriate for the space they're in, and that's something that you would talk to your installer about. You might not want to put a heat pump water heater 2 feet away from a bedroom in the basement or a family room in the basement because of the issues I talked about. But if you have an unfinished basement and you're not using it for living space, they would be a perfect solution to the water heating problem. So there's financial help available for all income groups. For low and moderate income, there's a term called the area median income. This is an actual statistical record that's kept of average income. And there are two programs that NYSERDA runs based on income. If your income is less than 60% of the area median income, you would qualify for what's called the Empower program. And simply, this is the list of family size and income eligibility. If your income is greater than 60, but less than 80% of the area median income, you would qualify for what's called assisted home performance. And here's the income qualifications for that. All of this information, I believe, is available on the website, or you can contact the HeatSmart staff to get it. There's a third class of people, which is people whose income is above 80% of the area median income. And there's actually programs that are available to you also with incentives. So kind of summarizing, if your income is less than 60%, your household income, you are eligible for a $10,000 grant for insulation and energy efficiency and heat pumps through the Empower program. If it's between 60 and 80%, there's a matching grant, which means that 50% of the cost of the work up to $5,000 is available. And it covers insulation, air sealing, and heat pumps. And for everyone else, it's not really a grant, it's an incentive that varies with the kind of work that's done. And very briefly, there's also low interest financing available for folks using the assisted home performance and comfort home programs. So you can do an assisted home performance project, you can have a certain percentage of it covered by the grant, and the balance of it would be eligible for financing through the low interest financing programs. So the comfort home incentives, this actual chart was provided by NYSERDA, and the word cost is really not the appropriate word, it's really incentive. So the actual incentives are based on the amount of work that's done. So if you have a basic incentive, if you just do air sealing and duct sealing and insulate the ducts at $500, and as you add insulation, attic and rim joist insulation, it goes up to $1,000. If you then add the walls insulated and insulate the floor, for example, a garage ceiling, which is the floor of a bonus room, it goes up to $2,500. And then if you add Energy Star windows, it goes up to $4,000. So the incentives are not based on your income, they're based on the work. And you can discuss this with your contractor when he comes to see you. So there's incentives for heat pumps, utility rebates for cold climate air source heat pumps, and for ground source heat pumps, and for heat pump water heaters. There's a federal tax credit, which is $300 for air source heat pumps and heat pump water heaters, and 26% of the entire cost of the project for ground source heat pump. And there's even incentives for large building, which is a utility rebate for buildings that require more than 300,000 BTUH per hour to heat. To give you an idea, most houses use 100,000 BTUs or less. So a 300,000 BTU building is a large building. So what do people install in HeatSmart Central New York? Well, a significant number of our clients just did the installation and air sealing only. And that's the yellow bar, or they did insulation and air sealing as part of a larger product, which was a slightly larger group of people. When we looked at air source heat pumps, the vast bulk of the air source heat pumps that have been installed were ductless mini splits. There was a few cold climate air source heat pumps that were ducted with dual fuel, which means that the existing furnace was kept in place and the heat pump was added. And there was at least one job that was a ducted cold climate air source heat pump. But as you'll see, the predominant type of heat pumps that have been installed have been the ductless mini splits. So ground source heat pumps is similar. The horizontal loop is represented by the purple violet line bar, and the vertical loops are represented by the blue bar. There was at least one project that had an open loop, and we won't talk about that. They're very rare and not really recommended. And the most common, slightly more common, was vertical loops than horizontal loops. But both types are obviously available depending on where you live. There is a house in Tipperary Hill that's got to be 80 years old, and it basically is sitting on a street where every house is about 10 feet away from every other house. So his house was literally the width of his driveway is what separated him from the house on one side and on the other. And he had a vertical ground source heat pump. They literally drilled his well down the center of his driveway, and when they were done, it was all patched up, and there was no evidence that it was even done. So anything is possible. You can have vertical loops anywhere as long as the drilling rig can get at it. And if you have lots of land, you can have a horizontal loop installed. And finally, heat pump water heaters. So what have we done in the first 2 years of HeatSmart in terms of global impact? Well, we've been removing about 360 tons a year of carbon dioxide. We've taken 71 cars removed from the road every year. We have eliminated emissions from burning 756 barrels of oil, and we have sequestered emissions by planting 114,600 new trees over 10 years. Now, these are equivalents. They're not additive. They're just, depending on how you want to measure, this is what we've done. So where to start? First, sign up for a home assessment, find out what the experts say about the possibilities, learn more about the technologies, consider financing and incentives, and get the work done. You can spread the word. We do open houses. Before COVID, we were literally having folks open their houses up for us to literally visit, and we can do it now with Zoom. So you can help us out by using your house after the work is done for an open house so other people can see the work. You can volunteer, contact us, we're here to help. So really quickly, who does the work? What's important here is that all the installers who do work for and with HeatSmart have been fully vetted, not only by HeatSmart, because we've actually vetted them and interviewed them and met with them, but they are also vetted by NYSERDA, because all of these contractors and participate in this program have to meet incredibly rigid standards for quality control and quality management and excellence. They are all subject to quality assurance inspections from NYSERDA. So they are the cream of the crop in terms of the contractors who do this kind of work. So we vetted them, we meet with them on a regular basis. We make sure that the work they do is of high quality, so that you can be assured that if you hire any of these contractors, you will have really excellent work done. You'll notice that they don't all do everything. ACES and NP are basically geothermal heat pump installers. ACES also does heat pump water heaters, and NP does air source heat pumps and heat pump water heaters. Breathe Easy partners with Zero Draft, but he's an HVAC contractor, and he installs air source heat pumps and heat pump water heaters. And Halco and Snug Planet basically do everything. So they do home performance, they do the air sealing and insulation, they do geothermal and air source heat pumps, and they also do heat pump water heaters. And Simply Installs also does insulation and air sealing, and does air source heat pumps and heat pump water heaters. So you have a choice of contractors based on your needs and based on the work you want done. And finally, NYSERDA has set up clean heating and cooling community campaigns all over the state. I think there's 17 of them geographically all together. Here we are sitting in the middle of the state here. If you happen to live outside of our 5-county area, let us know, and we can set you up with whoever's appropriate in handling the region that you live in. And finally, Lindsay Spears, our campaign director, and She's your primary contact person, and thank you very much. I'm done.